On this one, we want to find the equation in terms of x of the line through the points negative 5, 3 and 5, 4. So to find the equation of the line, there are multiple ways to do this. I like to use point-slope form. And point-slope form is y minus y1 equals m times x minus x1. So to fill out this format, you need m, which stands for the slope. And we have a formula for calculating slope. That's y2 minus y1 over x2 minus x1. And we also need a point on the line, x1, y1. We are given 2 points. So we have a point for the x1, y1, and we need to calculate that slope. So I'm going to let one point be x1, y1, the other one x2, y2. We'll substitute into the formula. That's 4 minus negative 3 over 5 minus negative 5. Simplifying those double negatives, we get 4 plus 3 over 5 plus 5. We have 7 over 10 for the slope of our line. Now I can substitute into that point slope form. I'm using this as my x1, y1. So we have y minus negative 3 equals 7 over 10 times x minus negative 5. And when we simplify those double negatives, we have y plus 3 equals 7/10 times x plus 5. And we have found the equation, but we want to find the equation in terms of x, meaning that x is the variable on the one side. So let's continue to simplify getting y by itself. So I'm going to distribute to get rid of these parentheses. We have y plus 3 equals 7/10 x plus 35 over 10. And that can be reduced. We have y plus 3 equals 7/10 x. 5 goes into 35 7 times. 5 goes into 10 2 times. And we'll subtract 3. We have y equals 7/10 x. We need a common denominator to combine those together. So I'm going to multiply by 2 over 2. That's negative 6 over 2. And 7 over 2 minus 6 over 2 is 1/2. We have y equals 7/10 x plus 1/2. On this example, we want to graph the line described by y plus 3 equals 5, 6 times x plus 3. This is a linear equation written in point-slope form. Point-slope form is y minus y1 equals m times x minus x1. Our equation is y plus 3, or if you want, you could write it as y minus negative 3 equals 5, 6 times x minus negative 3. And I wrote it in this way so that you could see that the m, which stands for slope, lines up with the 5, 6, and the x1 lines up with the negative 3, and the y1 lines up with negative 3. So this gives us a point on the line of negative 3, and a slope of 5, 6. So without doing any calculation, we can graph this line. We can plot that point, negative 3, and we can use the slope as rise over run. and that gets us a second point on the line. So we're going to rise 5 and run 6, and we can connect those 2 points with a straight line. So that gives us the graph from point slope form. Consider the equation negative 7x minus 3y equals negative 6. A line parallel to the above line would have a slope of, and there's a blank here, a line perpendicular to the line above would have a slope of blank. So we need to know some facts about parallel and perpendicular lines. Parallel lines will have the same slope, and perpendicular lines have negative reciprocal slope. So we're going to start by identifying the slope of the given line. Negative 7x minus 3y equals negative 6. I'm going to solve for y by adding 7x. That's negative 3y equals 7x minus 6. We'll divide by negative 3. And y is equal to negative 7 over 3x plus 2. Now that this is written in slope-intercept form, we can see that the slope is negative 7 over 3. Since parallel lines would have to have the same slope, we would write negative 7/3. A perpendicular line would need to have negative reciprocal slope, so the opposite sign will be positive and the reciprocal, interchanging the numerator and denominator. So that slope would be 3/7. Find the equation in standard form of a line with slope negative 10 over 7 that passes through the point 1, 9. So I'm going to start with point slope form. Y minus y1 equals m times x minus x1. And we're going to substitute the slope and the point into the equation. We have y minus 9 equals negative 10 over 7 times x minus 1. So we have found the equation, but this equation is in point slope form, and we want to write the equation in standard form. Standard form is when you have ax plus by equals c. You want the x and the y on the same side of the equation and the constant on the other side. So I'm going to manipulate the equation that we found into that standard form. So what I'll do is I'll use the clearing fractions technique to get rid of this 7. I'm going to multiply by 7 on the left and multiply by 7 on the right. That cancels the 7's on the left. So I have 7 times y minus 9 equals 10x, 10 times x minus 1. I'll use a distributive property. That's 7y minus 63 equals 10x minus 10. And now I'll group the x's to one side. I'm going to subtract 10x. And I'll get the constants on the other side. I'll add 63. So on the left, I have negative 10x plus 7y equals 53. And one last thing here, with standard form, we typically don't like our leading term to be a negative, so we're going to get rid of that negative by dividing every term by negative 1. That would give 10x minus 7y equals negative 53. So we have our standard form of the equation with slope negative 10 over 7 passing through the point 1, 9. This question says solve the equation for the given variable. If your answer is a fraction, write it reduced. Do not convert the answer to a decimal. We have w plus 7 that's w plus 2 over 4 plus 5 equals w plus 5 over 5. I'm going to solve this using the clearing fractions method. The clearing fractions method, I'm going to first find the least common multiple of the denominators 4 and 5. And the least common multiple, I could just multiply these two numbers together to get 20. With the clearing fractions method, we want to multiply that 20 onto both sides of the equation. On the left-hand side, I'm going to distribute that 20 to both terms. This gives 20 times w plus 2 over 4 plus 20 times 5. On the right-hand side, I can start reducing. 5 divides into 20 4 times. This will give 4w plus 5. On the left-hand side, 4 divides into 25 times and gives 5w plus 2. 5 times 20 is 100. I'll use the distributive property. 4 times w plus 5 is 4w plus 20. On the left, the distributive property is 5w plus 10 plus 100 equals 4w plus 20. We'll combine like terms to get 5w plus 110 equals 4w plus 20. I want to collect the w's on one side, so subtract 4w on both sides. This gives w plus 110 equals 20. I'll subtract 110 on both sides to give w equals 90. 20, that's negative 90. Negative 80. No, negative 90. So my solution is negative 90. I would like to show you an alternative method if you've not had enough practice with the clearing fractions method. So we're going to start off with w plus 2 over 4 plus 5 equals w plus 5 over 5. So instead of the clearing fractions method, I'm going to combine the terms on the left-hand side together. When you combine them, they need to have a common denominator. So right now, we have a denominator of 4, and the number 5 is 5 over 1. That common denominator will be 4, so I'll multiply by 4 over 4. This gives w plus 2 over 4 plus 20 over 4 equals w plus 5 over 5. Now that I have a common denominator on the left-hand side, I can combine those into a single fraction. That's w plus 2 plus 20 over 4. That's w plus 22 over 4 when we combine like terms. I'm copying the right-hand side down. And now I will multiply both sides by 4. And this cancels out the 4 to give w plus 22. On the right-hand side, I'll distribute the 4. That's 4w plus 20 over 5. And I'm going to multiply both sides by 5. This cancels the 5 on the right, leaving me with 4w plus 20 equals, and I need to distribute that 5, 5w plus 110. I'll collect the w's on one side, so I subtract 4w, that's w plus 110 equals 20. We'll subtract 110 to get w equals negative 90. For this question, we want to solve the formula a equals 1/2 h times a plus b, and we want to solve for the variable a. So I'm going to rewrite the problem. A equals 1/2 h times a plus b, and my variable I'm trying to solve for is a, which is inside the parentheses. Now before I can solve for that a, I want to get rid of all of these values that are attached to the parentheses so they go away. So I'm going to start by multiplying by 2 on both sides. And the 2's will cancel. We have 2a equals h times a plus b. Now I'll get rid of that h. That h is multiplied, so I'll divide. That gives 2a over h equals a plus b. And now since all of the numbers multiplied on the parentheses are gone, I don't need the parentheses anymore. And I can solve for a by subtracting b on both sides. We have a equals 2a over h minus b. Solve the following formula for b. We have y equals 3 times 3a plus 5. So in this example, the variable that I'm trying to solve for, b, is inside the parentheses. So I'm going to get rid of the parentheses first by distributing this 3. That gives y equals 9a plus 15b. And I'll solve for b by isolating it. I'm going to subtract 9a. We have y minus 9a equals 15b. Divide both sides by 15, and we have b equals y minus 9a over 15. For this question, we want to find the equation in standard form of the line with slope of 6/5 passes through the point 8, 1. So we were given the slope point. I'm going to use point slope form, y minus y1 equals m times x minus x1. And we use point as x1 and y1 and the slope as m. This gives y minus 1 equals 6/5 times x minus 8. And we have the equation of the line, but the equation right now is in point slope form. We want to write it in standard form. Standard form is ax plus by c. We have some extra rules where we want no fractions, and we don't want a negative front. So because I don't want fractions, I'm going to go ahead and get rid of the fraction right now. I'm going to multiply the left-hand side by 5 and the right-hand side by 5. This will cancel the 5's out. And I have 5y minus 5 equals 6x minus 48. I use the distributive property on the left, distributing the 5, and the distributive property on the right, distributing the 6. Now I want to collect the x's y's to the left. So I'm going to subtract 6x. And I'm going to collect the constant on the other side, so I'll add 5. This gives negative 6x plus 5y equals negative 48 plus 5, and that's negative 43. So one final thing, remember I don't want this negative leading on my standard form, so I'll divide every term by negative 1. And we get 6x minus 5y equals a positive 43. In this example, we want to solve the following formula for x. We have y equals 7mx plus 2b. I want to rewrite the equation so that we have x equals. So let's start by isolating the whole term that the variable is in. So I'm subtracting 2b. That gives y minus 2b equals 7mx. So we've isolated the term that contains the variable x. Let's get rid of the 7m. 7m is multiplied, so to get rid of it, we divide by 7m on both sides. This gives x equals y minus 2b over 7m. So we solve the formula for x. Write y equals negative 3 halves x plus 9 halves in standard form. Standard form is ax plus by equals c. You want the x and y terms on one side of the equation and the constant on the other side. Here we have y equals negative 3 halves x plus 9 halves. So we want the x and y terms on the same side, so I'm going to add 3 halves x on both sides. This is 3 halves x plus y equals 9 halves. Now we do have the x and y terms on one side and the constant on the other side, but we want to take this a little bit further. We don't want to have any fractions in our answer. I'm going to clear fractions by multiplying both sides by 2. We'll distribute that 2 to both terms. It cancels when you multiply by the first term, so we get 3x. And the second term, 2 times y, is 2y. The 2's cancel when we multiply it on the right-hand side, and we get 9. So our standard form is 3x plus 2y equals 9. In this example, we want to solve the equation for the given variable. If your answer is a fraction, write it in reduced fractional form and do not convert the answer to a decimal. Our equation is y over 5 plus y over 4 equals 7 over 6. Now to solve this, I'm going to use a method called clearing fractions to get the least common multiple of 5, 4, and 6. Now, when I look for the least common multiple, I'm looking for a number that all of these divide into evenly. I'm going to show you a strategy that you can use to find the least common multiple. That strategy involves writing the prime factorization. So since 5 is prime, the prime factorization of 5 is just 5. Prime factorization of 4 is 2 times 2. 2 and 2. 2 is a prime number. And the prime factorization of 6 is 2 times 3. Once you have the prime factorization, you're going to look for factors that are in common. I have a factor of 2 that's in common. Because it's in common, I don't need to repeat it. So for my least common multiple, I'm going to write down one factor of common 2. But I also need to have all of the other unique factors. So I'm going to also multiply by 5, multiply by another 2, multiply by 3. This gives us a least common multiple of 60. 5 divides evenly into 60, 4 divides evenly into 60, and 6 divides evenly into 60. We're going to multiply that least common multiple onto every term. And this will clear the fractions in the problem. 6 divides evenly into 60 10 times. So on the right-hand side, we get 70. I'm going to distribute that 60 to both terms. We have 60 times y over 5 plus 60 times y over 4. 5 divides evenly into 60 12 times, so we get 12y. 4 divides evenly into 60 15 times, we get plus 15y equals 70. 12 plus 15 is 27, so we have 27y equals 70. We'll divide by 27, and this gives y equals 70 over 27. 70 has factors of 7 times 2 times 5. 27 is 3 times 3 times 3. There are no common factors, so the solution here is 70 over 27. In which sets of numbers would you find the number 41 over 11? And the sets are irrational numbers, integers, rational numbers, whole number, real number, natural number. Now, in order for us to know whether 41 over 11 is in these sets, we have to know the definition of these sets. So I'm going to start with the easiest. That's the natural number. Natural numbers are our counting numbers, 1, 2, 3, 4, 5, and so on. You can see that we can eliminate this quickly. We have a fraction, 41 over 11, and our counting numbers do not involve fractions. The next one that's pretty simple is the whole numbers. The whole numbers are counting numbers, 1, 2, 3, 4, 5, and so on, and then we also include 0. So once again, these do not involve fractions, so 41 over 11 is not a whole number. The next easy set to look at are the integers. The integers are our counting numbers, 1, 2, 3, and so on. Include 0 with the integers, and we also include the opposites of our counting numbers, -1, -2, and so on. Once again, we don't have any fractions, so 41 over 11 is not an integer. The rational numbers, the definition of a rational number is P over Q. So here we're introducing the fractions. P over Q, where P and Q are integers, and Q is not 0. The denominator is not 0 because division by 0 is undefined. So we do have a fraction, and our numerator and denominator are integers. So we do have 41 over 11 being a rational number. This also allows us to eliminate irrational numbers. Irrational numbers are any numbers that are not rational. We just said 41 over 11 is rational, so it's not irrational. Finally, we have our real numbers. Real numbers are any numbers that we can put on the number line. That includes decimals, fractions, radicals, anything, you name it, except for imaginary or complex numbers. So 41 over 11 is a real number and a rational number. Thank you for checking out my videos. Have a great day.